So when we're thinking about process from this point of view, process is the central idea, and we look at process from different perspectives, whether it's who, what, why, how, where, and when. So just different perspectives on the same thing. It gives us a unifying idea. And the potential that drives the flow is the why that drives the change in flow, and the how is the function or the change or the method that makes that change against the impedance, which is the opposition. And impedance is made up of resistance, which is dissipation of energy. I'm using the electrical terms there. Capacitance, which is the storage of potential, the accumulator, and inductance, which is the storage of flow and causes a delay. The values are really fundamental. So engineering ethics is a subject we really got to develop, and people are beginning to do that. But we make decisions based on preferences, preferences based on values. Values are the worth that we give to something. Quality is the degree of excellence, which is the state of having the highest value. Quality for science is precise truth. Again, we have a debate about what we mean by that. Quality for engineering is fitness for purpose. So practical rigor is a bigger idea, in my view, than logical rigor. Logical rigor is necessary but not sufficient. What engineers have to do, what all practical people have to do, is to make things work. From moving from a vision to a reality. Delivering a system that is valued in a variety of ways, and managing this creative tension. So we use appropriate models, which may be sensible approximations. We have to use judgment. The biggest attribute that the best engineers have is the creative foresight, being able to see what may happen to your system and to minimize the unintended consequences. Coming to the end, truth is to knowledge as risk is to action. This is why I think risk is so important. Most people would agree that truth is an incredibly important idea. But to me, risk is of an equivalent importance. And why do I think that? Well, if we look at knowledge as compared to action, the intention of knowledge is to achieve understanding. The intention of action is to achieve an outcome. Truth or dependability is an attribute of correspondence of our understanding with the facts, because there you get a problem with what is a fact. And if you can get into an infinite regress. But risk is an attribute, or lack of, correspondence of an outcome with consequences. So truth is, again, people have different views about truth, so I'm just giving one view here. A degree between true and false. So the old classical idea that you could only have be true or false binary. And then the later ideas of degrees of truth in mathematical logic, and fuzzy sets and fuzzy logic as one aspect of that. Degree of success between failures. So it's an inverse relationship here, true and false, failure, success. But to me, risk is as important as truth is. Now, again, this is going to film, so if you're really interested in studying this slide, and it's actually in my Bridges book as well, so don't try to study it now. But it's my version of purpose, process, and people. Purpose, process, and people. And this is intended to show a sort of interaction diagram for current thinking, and this is how we would hope systems thinkers think. And notice that we're talking about purpose, which is about basics, firming the foundations of why we are doing what we're doing. Here is process, which is about structure, funnily enough. It's about the way things relate to each other. Not many people think of a building like this one as a set of processes, but that's what it is, because there are forces going around in the beams and the columns, which are actually changing. Maybe slowly, if it's rather static, but if there was to be an earthquake suddenly, there would be some very dynamic forces. And then working well, and that's about people, it's about the soft things. And at the middle here is integration, people, purpose and process. So if you're interested in this, have a study of this at a later date. You can't take it all in now. But this is what, to me, joined-up thinking is about. So, where is systems thinking? Well, just about everywhere. Sustainable engineering, joined-up government. I was very forcibly struck by the case of Victoria Clambier. You remember the little girl who died many years ago, was murdered by her foster parents? And you read that story and you realise it was about lack of joining up. Information over here, information over here, information over here, information over here, not being shared. So each little piece of information said, no, not really a problem with Victoria. Had they put it together, they would have known they needed to act. So just the lack of sharing information. Such a powerful story. And it's not on its own. There are so many stories in healthcare like that. I've experienced the NHS on many times. I said a pacemaker, I've had other health problems too. If you have, you'll know the NHS is in crying out for systems thinking. Criminal justice, managing terrorists, climate change. Now, Patrick last week challenged a number of people, what are the grand challenges facing us? I've summarised some of the emails that were sent around in the Systems Centre here in Bristol. And these are some of them. Infrastructure, lifelines, transport, food, smart energy, economics, growth, sustainability, personal freedom, and against security. You know, we go to the airport and they make you take shoes off and all that stuff, personal security. You think, well, that's good because I hope that there isn't a bomb on the aeroplane and that they'll have discovered the bomb in somebody's shoe if there is one. But, you know, it's a very difficult balance to draw, isn't it? If you're responsible for the security of an airline, you know how hard this problem is. Well-being, well, we've heard about David Cameron and his happiness. But the meta-challenge really surrounding all these grand challenges that are facing us as a society, as a human race, to me is systems thinking. How do we convince people of the need? So here we are. What are the benefits of systems thinking? Well, hopefully it promotes us to think in a joined-up way. It integrates to provide synergy, and what we mean by synergy is just that the whole is more than sum of the parts. Some people can't accept that simple thing, but normally I explain it by thinking about us. If you look at your subsystems, your bone structure, your blood circulation system, your nervous system, your brain and all your nerves, any system inside you, none of those systems on their own can walk or talk. Put them together in you, and it makes you who walks and talks and has many other attributes as well. That's emergence, and that's synergy. Evolution has created perhaps the best examples of synergy that we have. So it's beyond science, it's beyond truth, it's about action. It addresses complexity. The whole movement about systems complexity, which arose largely out of mathematics and physics, is really got to be addressed in a systems thinking way, in my view. We need to be much clearer about what we mean by practical rigor. When we are being good engineers, when we're being good practitioners, whether we're a doctor and an economist, but practitioner is distinct from a theoretician, what is being rigorous mean? In my view, practical rigor, as I've said, is about having a clear vision of what we're trying to do, what the purpose is, what the underlying ethics of that purpose is, how we've shared it, and then moving towards that purpose, using everything that we have available to us to do that with. And so our hard systems, our understanding of hard systems, are embedded in soft systems, because we can only understand the physical world through our brains, collectively. Thank you for listening.